This is an orthokeratology case where the patient has a fair amount of refractive cylinder. It does correspond pretty nicely with the corneal cylinder, and it's not fully corrected with the lenses that the patient's currently using. And trying an EDS over refraction didn't seem to help. It seems like really correcting that remaining cylinder is what most improves the patient's vision. So in this case, I think it would be a good idea to try an oval optic zone to see if we can mold out a little bit more of this corneal cylinder. And to do that, we do need to switch to GSIM mode because we're going to be changing the vertical meridian of the lens independently of the horizontal meridian. In fact, the horizontal meridian, because the post-sphere refraction was pretty close to plano, at least spherically, we probably don't need to change that at all. We're just going to change the demand as well as the size of the zone in the vertical meridian. So for the right eye, first thing I'm going to do is switch to GSIM mode. It's going to change our graph a little bit. And in 50% mode, we're going to go from the traditional 6.2 and 6.8 down to a 5.6 and 6.2. So I'm going to change this to 5.6 and change this one to 6.2. Okay, so now if we spin around to the bottom, you'll see because we're in 50% mode, the inferior meridian is the same. Here in the oblique meridians, we're about halfway in between our original treatment zone size and our new treatment zone size. So we've kind of got a graded change going across. If we go back to our original 180 meridian, our power there was a plus 1.23. And in the right eye, I believe the patient had a diopter and a half of remaining cylinder. So our differential for the vertical meridian is going to be 2.73 approximately. So back to the vertical meridian, 50%, we're at 1.99, so I'm going to increase the demand a little bit. And we're pretty close to 2.73 now. So vertically, compared to horizontally, we have about a diopter and a half more demand or power, and that should hopefully mold out some of the cylinder. I am going to just spin through the different meridians to make sure the tear graph looks fairly stable, and it does. Okay, and then in the left eye, same thing. We're going to switch to GSIM mode. We're at 1.22. I think in the left eye, we only had a diopter of remaining cylinder, so our target in the left eye will be 2.22. First thing we'll do is go to 50% mode and change the sizes of our OZ and IC. So 5.6, 6.2, and then we're going to bump this up a little bit, pretty close to 2.22. So we should have a similar appearance here, where in the oblique meridian, everything is kind of in between our horizontal and vertical. Our differential is about a diopter, and that will hopefully mold out the remaining cylinder that's in the left eye. So that's how I would go about creating an oval optic zone specifically for the purpose of molding out corneal cylinder. Hope this helps your patient. Best of luck, and thanks for watching.